Let's look at equations with variables on both sides when we're trying to solve. Now when we have these, we're going to have two new types of solutions that we can get besides just integers or numbers, real numbers. So you have the identity solution that you can also get with this. And this is when an equation that is true for every value of the variable. So you can plug in 2 and your equation is still true. 3, your equation is still true. 0, your equation is still true, and so forth. So any number you plug in for that variable, you're still going to get a true equation. Now, an equation that has no solution, if no value of the variable makes it true. So you'll end up with something looking like 2x equals 2x plus 1. Well, you know 2x and 2x plus 1, they don't equal each other, so you know this is not true and this is going to be a no solution equation. Now when we are solving variables on both sides, and you can use these steps really when you're solving any type of equation, you need to go through these 7 steps. The first step is to distribute. So if you have parentheses and need to distribute, you need to do that. Even if it's on both sides, you need to do that. The second thing is optional, but I highly suggest you clear all of your fractions. Remember, we multiply by a common denominator. The next one, you're going to combine all like terms on the LHS. That means left-hand side. So just on the left-hand side, if there's any terms you can combine, combine them. Then you're going to do the same thing for the right-hand side, and that's RHS, just so you don't have to write all of that out. Alright, so after you've done those 2 steps, you're going to ask yourself, is there a variable on both sides? If there's not, leave that alone, go to the 6th step. If there is, you need to move one to the other side by adding or subtracting. So you need to move that variable to the other side. And it doesn't matter which side you move which variable to. So once you've done that, you need to ask yourself which side the new equation is the variable on. Then you say left or right. Then you're going to ask yourself, is there a number being added or subtracted on that side of the equation that the variable's on? If there is, then you need to move it and get rid of it. And you do it by doing the opposite, which means you add or subtract it to move it. Then the last step is there a number next to, which meaning like 2x, or under, which means like x divided by 3, the variable. And if you do have something under or next to the variable, you're going to get rid of it by multiplying or dividing. So these 7 steps will get you through any equation successfully. Alright, let's look at some examples. This first one, 6x minus 2 equals x plus 13. I always draw my line down to make sure when you're doing one side, you're doing something to one side, you also do it to the other. Now, first thing, we don't need to distribute, okay, and we have no fractions. So we got the first 2 steps done. Now on this side, I cannot combine any like terms. They're all different. And same thing on this side, so I cannot combine anything on the right hand or the left hand side. So now I need to do step, 5. There is a variable on both sides. So since there is, I need to add or subtract to move one variable over. Now I'm going to move this x. You could have done the 6 too. Alright, so this is a positive x. I need to do the opposite, and that's subtracting an x, because that needs to be 0. So you do that to both sides. 6x minus x is 5x. Still have the minus 2, and now I have only 13 on that side. Okay, now we have a 2-step equation, and we're on to our 6th step, which is, do we have a number also on the same side as our variable? Well, here's our variable, and we do. We have a subtract 2 on this side. Oh, I need to stop yawning. Alright, so I need to add 2 to both sides to get 5x equals 15, and now I have a number next to my variable, so I need to undo that by dividing by 5 on each side to get x equals 3. And there's my answer. Now this second one, 7k minus 4 equals 5k plus 16. Notice there's no parentheses. I don't need to distribute. No fractions. I don't need to get rid of my fractions, but I do have a variable on both sides. I'm going to subtract 5k from both sides. 7k minus 5k is 2k. And remember, 5k minus 5k, that zeroes out. So I have 2k minus 4 equals 16. I'm going to add 4 to both sides to get 2k equals 20, and then divide each side by 2 to get k equals 10. Now, number 3, again, I don't have any fractions. I don't have any parentheses. So I go to my next step. I do have variables on both sides, so I need to move one of them. I'm going to again move my 3x. This is a positive 3x, so I've got to subtract 3x from both sides. 4x minus 3x is x. I do have a number attached on the same side as my variable, so I need to move that by subtracting 3 from both sides. 6 minus 3 is 3, and 3 minus 3 is 0, so I'm left with x, so x equals 3 is my answer. Now, number 4, I do have parentheses, so I need to distribute. 2 times c is 2c. 2 times 6 is 12, and notice it's a subtract there, so I keep it. This side, I have 9c plus 2. Now, I don't need to combine like terms on the left-hand side, nor the right-hand side, so I can skip those 2 steps. But notice I have c's on both sides of the equal sign, so I need to move one over. I'm going to do that by subtracting 9c from both sides. 2c minus 9c is negative 7c. I still have a minus 12, and I'm left with 2 on this side. So I have a number attached to this side, same side as the variable. So I'm going to add 12 to both sides to move it or get rid of it. 2 plus 12 is 14. I'm left with negative 7c. Notice negative 7 is attached to the c, so I need to undo it by dividing by negative 7 on each side. And 14 divided by negative 7 is negative 2. Number 5, again, I need to distribute. So 4 times x is 4x. 4 times 5 is 20. Now, variables on both sides of the equation. Now, when you only have 6x on this side, and that's it, what you need to make sure, and you have a variable also on this side, is you move your variable from this side over here to this side. It'll make things a little bit easier. So if I do 6x minus 4x, that's going to give me 2x. Oh, my goodness. And 4x minus 4x is just 0, and I bring my 20 down. Now all I have to do is divide by 2 on both sides, and 20 divided by 2 is 10. Okay, number 6, again, I have parentheses. I need to distribute, but I have no fractions, so I don't have to worry about that. Alright, so 5 times 1 is 5. 5 times a is 5a. Notice it's subtraction, so I keep my subtraction. Alright, this side, I have all my like terms combined on the left-hand side, as well as the right-hand side, so I don't need to do that. Now, I do have a variable on both sides, so I need to move one. I decide I'm going to move this minus 5a, so I need to add 5a to both sides. A plus 5a is 6a. My goodness. I still have my plus 5. Then I have 5 minus 5a plus 5a. That becomes 0, so I'm left with 5. Now I still have on this side, I have my number being added to my variable. So I need to subtract 5 from both sides. Now I do 5 minus 5 and that's 0. And that's okay. It's okay to have 0. Okay, so I'm left with 6a equals 0. Now I need to divide each side by 6. And you know 0 divided by 6 is 0. So my answer is just 0. Alright, now let's look at some equations that are actually going to have a no solution or identity answer. So if the equation has an identity, remember when any number we plug in for it, it's going to still work out to be true. I want to write identity, and if it has a no solution, I want to write no solution for my answer. I don't just leave it. I've got to make sure I write identity or no solution. Alright, this first one, negative 8x plus 14 equals negative 2 times the quantity 4x minus 7. Okay, my first step is to distribute. So I need to do negative 2 times my 4x, that gives me negative 8x. A negative 2 times the 7, which is a negative 14, but notice there's a subtract here, so it's really just a plus 14 since it's two negatives. Now notice I have negative 8x plus 14 equals negative 8x plus 14. They're the same thing, okay? Now if I add 8x to both sides, both x's go away, and I'm left with 14 equals 14. Since 14 does equal 14, that is true, and these three dots mean therefore, we're going to call it identity. And that's how I get an identity, if both sides equal each other. Now if you were up here and you notice, oh, both sides equal each other, you could have stopped there and automatically said identity. Alright, now on to 2. A minus 4a equals 2a plus 1 minus 5a. Now I don't need to distribute and I don't have fractions, but my left hand side has all the like terms combined, but my right hand side doesn't. So I need to do 2a minus 5a, and that's negative 3a. Now I still have the plus 1. Alright, now I have negative 3a equals negative 3a plus 1. We know this isn't going to be true, but let's keep working until all of our variables are gone. I'm going to add 3a to both sides, and I'm left with 0 equals 1. I know 0 does not equal 1. This is not true. Therefore, this is going to be a no solution. So when you have two numbers that don't equal each other, it's a no solution. When they equal each other, it's an identity. Alright, number 3, we have 6m minus 5 equals 7m plus 7 minus m. Okay, don't need to distribute, don't need to get rid of any fractions. This side's already got our like terms combined. This side I need to, so I have to do 7m minus m, and that's 6m. Still have my plus 7. Notice 6m minus 5 equals 6m plus 7. Those are not the same thing. So I could stop here and say no solution. But if I wanted to go ahead and get rid of my m's, I subtract 6m for both sides, and I get negative 5 equals 7. That is not true. So it's therefore a no solution again, because negative 5 and 7, they're not equal. Alright, number 4, I need to distribute right here. So I need to do 2 times 5 and 2 times 4x. 2 times 5 is 10. 2 times 4x is 8x, but notice subtraction right there, so I keep it. This side I have 10 minus 8x. Well, we know 10 minus 8x does equal the same thing, 10 minus 8x. So I could stop there and say it's an identity. But if I keep going, by adding 8x to both sides, I get 10 equals 10. And that is true. So it is called an identity. Alright, let's look at some practice problems. Okay, this first one, we've got a lot of distributing we need to do. This first side, 2 times 4 is 8, and 2 times 2x is 4x. Remember subtraction, so I bring it down. This side, 2 times x is negative 2x, and negative 2 times 5 is, actually it's a plus negative 10, but we can do it as minus 10. Alright, next thing, both sides, left and right, have combined like terms, so I don't need to do anything. I need to move one of my variables over to the other side. So this is a minus 2x. Need to do the opposite. I'm going to plus 2x for both sides. So negative 4x plus 2x, that's going to give me a negative 2x. I still have the 8 and the negative 10 on this side. Now, I need to move this 8 over to the side with the negative 10. So, since this 8 is a positive 8, I'm going to subtract 8 from both sides. 8 minus 8, 0, so I'm left with negative 2x, and negative 10 minus 8 is negative 18. So negative 2x equals negative 18. Now I'm going to divide each side by negative 2, and I get x to equal a positive 9, because a negative and a negative divided is a positive. So my answer is positive 9. Now number 2, we have all fractions. Now luckily they all have the same denominator, 8. So all I have to do is multiply the left-hand side by 8 and the right-hand side by 8. That leaves me with 7w equals 4w plus 6w. Alright, now I need to combine like terms. The left side is fine, we don't need to do anything there, but this right side I have 4w and 6w. I'm going to add them together, and I get 10w. Okay? Now I need my variable on one side, so I'm going to subtract 10w from both sides. 7w minus 10w is negative 3w. 10w minus 10w is 0, and it's okay to have 0. Then we divide each side by negative 3, and you know 0 divided by negative 3 is 0, so my answer is 0. Okay, on this side we have distribution that we need to do. So 3 times x is 3x, and 3 times 4 is 12. No subtraction, so I keep it. This side, 3x minus 12, we just leave it. We don't have to combine like terms. Notice both sides equal each other. So if they both equal each other, then you're going to have, of course, identity. But let's keep going. Make sure our variables actually do cancel out. So if I subtract 3x from both sides to move one of the variables over to the other side, I'm going to get negative 12 equals negative 12. And that is correct. It's true, so it's identity. Now number 4, we have 9x plus 3x equals 10. Minus 10 equals 3 times 3x plus x. Okay, the first thing I need to do is distribute. Right over here, 3 times 3x is 9x, and 3 times x is 3x. On this side, I need to combine like terms, which is the 9x and 3x to get me 12x. I still have minus 10. Now I need to combine like terms on this side. 9x and 3x, add them together is 12x. So I have 12x minus 10 equals 12x. Okay? Subtract 12x from both sides, and I get negative 10 equals, that's supposed to be 0. And we know negative 10 doesn't equal 0, so it's no solution. So remember, if you have two sides, no variable, but two numbers that do not equal each other, like negative 10 and 0, you get a no solution answer. But if you have two numbers, like negative 12 equals negative 12 written right here, they're the same number, then that's true, and that's called an identity solution.